Hi, everyone. I'm Adrian Hornsby, technical evangelist with AWS. I have the best slot of the day. It's when everyone goes and eat. So hopefully, folks are going to come back. If not, then Twitch is going to be cool. Today, we're going to talk about building serverless apps, but especially artificial intelligence-powered apps. There's been a lot of talk this morning about serverless and using Lambda API gateways and all that stuff. And I think one of the very cool use case of it, because of even triggering capability, is plugging all the services together. And I always see the cloud like a big Lego brick, which you can very easily put things together. So today we're going to talk about that and see, hopefully, you get inspired at building cool stuff. This is my background. I have about 10 years experience with AWS as a customer before joining AWS. So I've seen the cloud growing, and that's why I'm especially passionate about the fact that we don't have to manage servers anymore that much. I used to be a DBA. That was it was great, but it was absolutely useless for our business. Business was not to become great at managing database, but it was really to add business value to our company. So as soon as we got more high-level services, it was kind of a really just move for me to embrace those. And really, the story of this talk is really about that. How to build quick stuff, and especially interesting AI-powered stuff. I'm also an athlete climber, and I love ginger shots. So if those are two of your things, please do get in touch with me. That'd be cool. Because I travel a lot, and when I travel, it's always good to meet people that go and climb. So I don't have to think about talking and work all the time. Anyway, good. Today we're going to talk about a little bit some theories, just quick. Especially, I'm going to go through about 3 demos, code, architectures, how they run, how I deploy the solutions, why those solutions have been made. And let's try to make this super interactive. So if you have questions, by all means, just raise your hand. I'll try not to ignore you, I promise. If you do, just throw a pen, and I'll just have my attention full on you. So we're going to talk first about AI at AWS, because I think it's important to understand what is AI, what does it mean? I think for everyone it means something totally different, and then how we can use it to build cool AI-powered apps, especially mobile apps. I think we're going to focus on that. So I'm not going to go through the whole what is serverless. I think this is kind of represent the state of the discussions I have with most people. There's always that one in the room that says, yeah, come on, there's servers on the hood. Yes, there are servers. In fact, there are actually a lot of servers if you think about Amazon scale. But the underlying principle is really that I don't have to manage about that. And I don't have to worry about it. For me, the idea of serverless is more really that scales as I use it. If I don't use it, I don't have to scale it. I don't have to worry. I don't pay it, right? Especially as well that it has availability and fault tolerant integrated to it, right? Because if you think about S3, which by all means is actually serverless, it sits across different availability zones, right? By default, DynamoDB is the same. Right? A lot of those services actually have built-in fault tolerance, so this is something that I don't have to worry about when I build my applications, right? And I'm talking not necessarily for startup, even though this is very, very compelling use case for startup. You want to have least infrastructures as possible that you don't have to manage, that you don't have to pay if you don't get customers, right? But it's also valid for big, large enterprise because you can go fast. And going fast, it means that you are not at the mercy of this one guy in the garage that is just waiting to disrupt the entire business, right? If you think about Netflix, Airbnb, all those industries have been totally disrupted by, few guys, right? Airbnb is 5 guys doing the entire infrastructure of Airbnb. And Airbnb is the biggest hotellery companies in the world. They're actually booked by a lot of folds more beds per night than any other hotels, right? So, for me, that's the whole power of serverless. And if you think about serverless, there's also, I think, very important patterns that comes is event-driven. I think we don't talk about it enough, but the entire world, how we live, how we talk, how we interact, is event-driven, right? We don't go every 5 seconds, did you have breakfast? Did you have breakfast? Did you have breakfast? Are you hungry? Are you hungry? People usually tell what they have, right? Or if you are coming into the room, you're stating that you're here. I'm not asking every 3 seconds until the moment he is arriving. So the idea of polling versus pushing and event-drivens are really married together. And I think the event-driven idea is a lot better to the world than what is a classic polling, right? Continuous scaling, again, pay by usage is just a natural thing. So if you think about the entire idea, serverless is really exposing functionality versus everything else. And this is what I'm interested in as a developer. Because I don't want to spend time doing things that is not relevant for my business. I want my business to be competitive and fast. Therefore, I want to focus on that. All right? So let's talk about AI now. Because we had 3 or 4 sessions, 3 sessions about serverless. So I shut down all the slides regarding that. And they did a very good job at explaining what it was. So the rise of AI. If you think about AI is actually very, very old. It's 70 years old technology, right? In 1950, there already were talks about artificial intelligence, right? Machine learning and all this kind of stuff. The problem is that to be able to use machine learning and AI at large scales for businesses, it was a huge problem. It was very, very costly, right? And in Amazon, we started experimenting with machine learning already in '94. Right? This is the page of Amazon.com when it was only a bookstore when we hit 1 million copies. And when you hit 1 million copies, you have quite a few problems. Customers are lost. There's too many options. You don't know where to choose, right? So for us, it was very important, very early on, to focus on functions that gave users and customers the capability to have recommendations, right? So for us, this was kind of the emergence of customer-focused applications. And it didn't stop there, right? In fact, if you look at the advent of AI and the rise of cloud computing, they are pretty matched. And there's few reasons for that. If you think about algorithm initially, right? Only in 2000s we had some breakthrough in terms of algorithm, neural networks, especially convolutional neural networks that were made very easy or easier to compute very large-scale neural network. The second is data, right? Before the cloud, it was very, very expensive to store exabyte or petabyte amount of data. You had a customer had to invest in your own infrastructure to pay for that storage, right? And there simply was not enough money or a capability to store that data. And if you want to train neural networks, deep learning, you need enormous amount of data to train that. Because they are not just super smart algorithms that don't need training, they actually only are smart if the training is very, very good. And for that, you need a lot of data. The third is the advent of GPU accelerations, right? Again, this is all related to how you compute algorithm. And a lot of the deep learning algorithms are parallelized computations, right? And CPUs is not great at doing that. So GPUs have made enormous improvement in how efficient it was to compute very large-scale neural networks. So the advent of cloud, data, algorithm, compute that you could all of a sudden have on demand. You didn't have to buy all this computation power, all this storage to run neural networks. So the advent of cloud computing is directly correlated with the rise of artificial intelligence, and that's why we see it now. And in fact, this is exactly where Amazon is standing now. We offer data as storage, very cheap storage, any type of compute, especially we have a lot of GPU-enabled instances that allow you to run your deep learning algorithm, and all that on demand. So you don't have to invest in a very big infrastructure to run your neural network. I could talk about this forever, so I'm just going to switch off to another to more related to the topic. But if you look at how this has revolutionized us at Amazon, it's pretty massive. In fact, this AI is the centerpiece of pretty much all the innovation that comes out of Amazon recently. Whether you talk about Amazon Go, which is a store you can go and then you're tracked in real time. You don't have queues. You can just go pick up the food and leave the store without having to do anything else than just go and leave. Or drones, right? We have drone deliveries. And for those two examples, they are very heavily powered by AI, you can imagine. So all those technologies and all those things that have been made Amazon very successful, a lot of them we are exposing those technologies for our customers, right? So we end up with an ecosystem that is available for you to use, right? And that ecosystem range from very high-level services like Amazon Rekognition and Poly, what we're going to talk about today more, Amazon Lex, which allows you to create bots, chatbots, to very low-level frameworks like Apache MXNet or TensorFlow that you can run in what we call a deep learning Amazon image instances, right? Very easily. You can start using them pretty easily. So for developers, depending on where you are in the stack, whether you want to have high-level services or you want to get your hands dirty, there is a service for you to play with and to interact with and to create cool apps with. And in fact, all this has made machine learning and AI very popular on AWS. And there are lots of customers that have jumped on that to revolutionize what they're doing in the cloud. Whether we're talking about FraudNet that is doing fraud detection on the stock market, so Xylo that does what the famous Zestimate to give a price of a house in the market, simply by looking at the entire history of sales that happened, right? So there's a lot of companies that have really embraced AI and machine learning to step up their games. Today we're going to focus on two in particular, Amazon Rekognition and Amazon Poly, which are high-level services. So you don't have much to do. You don't have to manage the infrastructure. You don't have servers. It's just very easy to use thing for everyday developers like me, right? I'm not a PhD in neural networks, so I cannot do my own algorithm. I need to rely on smart people to do that for me. So first is Amazon Poly. Amazon Poly is very simple, high-level service. You give it a string, a text, and it will return you an MP3 file with a generated voice of that text. Now you might say, okay, yeah, well, that can be pretty dumb stupid, because if I give a string like today in Seattle, WA, it's 11F, do I want that voice to say what I said, which is pretty stupid? Actually, the answer is no, you don't. You would want that voice to return something pretty smart, right? Something like today in Seattle, Washington, it's 11 degrees Fahrenheit. And the voice does that in 40 different voices and supporting 24 different languages. So it works something like this. You give the string, and then Poly...
Today in Seattle, Washington, it's 11 degrees Fahrenheit.
Right, Poly returns to you the voice recorded as an MP3 file or as an audio stream, and then you can do whatever you want with it, right? Now, as I said, it supports context. Here in the first example, WA was transformed into Washington, and in the second, we want to have live and leave pronounced totally differently, right? So the system has to be smart and support this kind of contextual understanding.
We live for the music live from the Madison Square Garden.
And those are directly handled from the API. In fact, I can show you directly the API. It goes something like this. Do you see behind? Yeah. So if I call Amazon Poly, this is the API. Whoops. I'll show you. So this what it returns. It returns me a file called Johanna.mp3. On Mac, I need to play that file. Oops. Sorry, I don't remember my. Yeah, it's. yes, FB play. Oh, so, yeah. So I'll put this so you can see over there. So this is how I would play right away the MP3 file that is returned from the Amazon Poly API. So I call the API synthesized speech. I give it a text input, and the text is a string, and then I can play it.
It is such a wonderful live show.
Now
By
you
the
see
way, I live in Helsinki.
the voice is different. I called Joey, right? And you could call Joanna if you want. Depending on the voice ID, it will return a female or male with different accent. If you are into Scottish accent, that's totally possible as well. So there's a lot of cool stuff like this. Now it's also very good at pronouncing very complicated text like this one.
How much would a woodchuck chuck if a woodchuck could chuck wood?
Right. So last time I did this demo, I was in Tel Aviv Summit, and I said I'll give $1,000 worth of AWS credit to someone that actually is able to say this fast. Someone stood up and said it like this, so I'm not going to say that anymore today. But if you are into trying this out, please feel free. I did send the credits, though. Poly supports semantics as well. So, for example, if you would give a phone number, you don't want that phone number to be said like that.
Richard's number is 2,122,341,237.
So you can actually add semantic inside the text to describe this as a phone number. Right?
Richard's number is 212-234-1237.
Right. So in fact, there's a lot of support for different type of semantic. It's a standard, right? You can also make semantic for pronunciation. In that case, you don't want Kaja, but you would want Kaya.
My daughter's name is Kaja.
But you want something
My
like
daughter's
this.
name is Kaya.
Right, so you can alter the way you pronounce it. And in fact, it makes it very compelling service to do pretty advanced synthesizing, right? This is the speech synthesizer annotations that you can use around the text. If I would want my name to be spelled, I would use something like this. And if you're familiar with a customer called Duolingo, in fact, they are powered by Poly. Duolingo is an app that allows you to learn languages, right? So they use Poly to do the text synthesizers. So it's very natural and spoken, so that was very good for them to use that. Another customer doing cool stuff with Poly is Washington Post. And what they do is they send the articles through Poly so that you can listen to the articles being published, right? And these are added values for customers that are paid so that you can listen to a post on the go. And this is a case that we're going to do now. So this I already gave a little example of how the API is working. Now I want to show about first demos that we're going to go through called Polycast. Basically, Polycast is quite simple. You would have an RSS feed with some articles, blog posts, or stuff like this. And you send them to Lambda. Lambda extract those articles, the text from the articles, and synthesize the speech using Poly, and then store the result into an S3 bucket. We store also the feed so that you actually can put the podcast into iTunes and start playing those. So this is very similar to what the Washington Post has done, right? So let's roll out into the first thing. If you want to access the demo, it's also on GitHub. It's a project that was initially launched by James Siri and Piotr Lewodzki, and I just added some functionality for deployment on serverless and made the code a little bit more Adrian friendly. So let's look at the code. So first, this is the Lambda function. We already saw a bit how Lambda works. This is the Lambda function written in Python. It's first doing all the imports for library that I will use, right? So it's especially using a library called feed parser that allows me to take an XML file of an RSS feed and parse through it so I can extract elements. So I don't have to do XML parsing. If you know XML, you know how you want to avoid doing this manually. I'm importing a bunch of different libraries as well. So the core of the function really happens here. It's called the handler, and this is what is called by Lambda. And basically, what I give it an RSS URL, right? And I give it a name of a bucket. Then I do some logo. I initiate my Poly client. This is how easy it is to actually start using Poly in your application. You initiate a Boto 3. Boto 3 is the SDK for Python, Amazon SDK for Python, and I just create a client for Poly. Then I use the feed parser to parse all the feed with some text. And what I did, for each entry is there, I'm calling Poly to synthesize the speech. And what I do is I also take an hash of that particular feed so that I can store that hash into Amazon S3 so that I don't have to redo all those all the time, okay? And I'm using Joanna in this case. I also create what he calls a podcast.xml file, which is the whole RSS feed into an XML, so I can push it into iTunes, for example. All right. The second thing which I want to show is how I'm deploying that. So let's see that. Yeah. So now you might realize I'm using a Mac, and Lambda, in fact, doesn't support Mac. So when you create stuff locally that are a bit more complicated and that you are linking libraries, you need to be careful. If I'm using Python for Mac and I upload that on Lambda on Ubuntu, you can have some import errors for the libraries, right? So it means that locally, if I want to create a package of all my source code with all the dependencies, I need to use Ubuntu, right? So I'm using Docker, simply Docker here so let's go up. What I use here, I use Docker to be able to create an Ubuntu application or Ubuntu container. The only difference here is I also mount my file system with the project which I'm using so that I can access the Mac files on my Ubuntu container. So, and I mount it in a directory called working. So if I go there, now I'm Ubuntu, and I have all my files, right? Now what you would want to do ideally is, and that's the best practice, in fact, when you upload code in Lambda that has lots of dependency from different libraries, you want to push all those libraries inside one package so that you don't rely on the service Lambda to have those libraries, right? You want, for example, a certain version of a feed parser. You want a certain version of datetime. So if you do that, always package your application with all the dependencies. That means I need to have a zip file with all the dependency in there. And you see here what I've done is actually creating exactly this. I'll show you quickly how to create that. This is actually in GitHub as well. So what you do is go inside my Docker file. Then here I install some Python because I'm using Python. And then I do this, right? So I go in my directory. And what it does, if you look at this file, these are my library dependency. And you see I have some dependency with particular version that I want to use because I've developed my code with those versions, right? So what I do, I install the requirements in a folder called .vendor, right? So what it does is going to go collecting all those requirements, And that's the right way to do it. It means that when I'm going to test my function locally with those dependencies, it's going to be exactly the same dependency and libraries running in the cloud, right? So you see there's lots of dependency. In fact, there's a lot of crossed dependency, right? So there. And then if you go into there, you can see I have all the dependencies there, right? So these are all the libraries, binaries that have been installed. Then ideally what you want to do is, this is the procedure how you would zip this package. So you would take all those zip, you create a zip file, you add the podcast, and then you go recursively inside the folder vendor to add all the libraries. And when you do this, you end up with something like this. That you see, I have my package.zip that is being created, right? And then I can take this package.zip, go into let's say Lambda. Oh, this is Lambda. And then I can, let's say, create a function. I don't want any trigger here. This is a Python 7. And here, what I want is, where's my upload? They changed the console. Cool, upload. Here, and then I can take my whole file and start. I have quite a few projects, as you can see. This one. Oh, it's not there. Oh. Well, you get the idea. Sorry. What's that? Where is it? Do you see? Oh, yeah, Polycost. Sorry. Oh. There. Woohoo! And there I have my package, my zip file. Now you can pass some environment variables as well. This, I actually do need environment variables. I need to tell the region in which my bucket is in that case, because you'll see here I have this one that I need to tell during my execution. So it means I can use several buckets. So what I take, I just take that, and I can say, I think, West 1. Then I have another one. So let me actually go into, because I don't remember all the ones I need. This is the one I deployed before, so in case the demos would go bad. But yeah, so this is West 1, and that's pretty much it. Then I can choose my trigger. So I think the configuration, yeah, this podcast.handler. So the handler. The handler is the name of the file here, podcast.python. So this one, podcast.python. And then the name of the function, which is called execution. So here is python.handler. And then I can, I have an existing role here, and I think it's polycast, but I don't remember which one. Yeah, podcast. So I have a lot of stuff. There are. And then I can just create that function. Right? So when this created, you end up with something like this, which is my function. And now the interesting thing is that you also want to test, right? So for example, here, I'm going to show you how to test. The input function takes a JSON file, which as the RSS, the URL of the feed, and then the bucket where I actually want the MP3 to be there. And then I can just save in test. And this will just run the Lambda function. And you see here, this is my bucket. And I have nothing yet in there. And then slowly, there's going to be MP3 files created with an hash of all the articles that I see in my podcast. So this is going to run for a while, because there's quite a few of them. All right, like this. And you see here, I want to test like that. Now, how you would genuinely use this is you don't want to go in the console and invoke the functions. Yeah?
You did the AWS dependencies in your list. Do you have to do that?
I'm sorry, what?
You had some AWS dependencies in your list of libraries.
Yeah, so I use the Boto library because I also want to use it locally. I just include those dependencies. You don't have to. I like to package the entire set of libraries I'm using. So I do actually import AWS SDKs as well from my local, because then I can control that. And I would suggest if you have production workloads, always do that. So it means you don't rely on Amazon to make sure the SDK is not going to be, let's say, changing, right? Even though it will never. As a developer, I'd rather put all the nest inside my decisions versus having Amazon making sure that the SDK is fine. But by default, the SDK is included in Lambda by default. Yeah, so you wouldn't have to do that. Right. So I have execution that has worked. Right? Now, ideally, how you want to use this is you want to have triggers. And triggers is, for example, running every day at 12 automatically. So for that, you can add what we call a CloudWatch event trigger here, and I have a CloudWatch event that every day at 12 will run that Lambda function, so I can update every day my podcast. Right? So here, this probably has now finished, hopefully, and I have this file, and you see there I have a link to it. So now I can then take that link, load iTunes. Oh, where are you? iTunes. Oh, iTunes is gone. OK. Let's get out of there. Then I can open iTunes, and I can say a new subscribe to the podcast, give the URL, and that will download then my URL, my files. And then here I have directly the files that are available to play.
New post, author Jeff Barr, titled Catching Up on Some Recent AWS Launches and Publications. As I have noted in the past, the
right?
AWS...
So just to show how quickly, with the function, Lambda function, and Poly, I can already very fast turn, let's say, a podcast into, or a newspaper, or a media website into something that, it'd be good for blind people, for example. In fact, one of our customers in the Nordics has integrated their entire media website with Poly to just allow this kind of stuff. And this really, the function is on GitHub. You can start deploying this. It will scale to as much, as many invocations you do. You have nothing to do, right? So just a quick example of how easy to start using AI-powered service with Lambda. And do schedule it every day, and then you're good to go. So that was the first thing. The second service, which is great, yeah.
That's your question. You haven't covered the costs of using this service. Will you be doing that later?
Yeah, actually, I don't have slide. It's a good thing, actually. I did. The question is, I didn't cover the cost of those services. I'm happy to go on the web page price. After that, I haven't included those because I need to move some slides away. Sorry. It's per invocation, right? So that's it. So there's also a very generous free tier. I don't remember exactly. I'm sorry. Let's go on the website once we're done at the end.
5 million characters a month for free for the first year.
Oh, cool.
After that, pay as you go, $4 per million characters.
So there's a generous free tier, and then after that, it's $4 per million characters. Is that correct? Oh, awesome. So it's all right. You're not going to get bankrupt out of it, unless you want to do the entire Gutenberg publications. That's another thing. I'm not responsible for what you do after that. The second service, which I think is great if you want to build very fast applications, is Rekognition. Rekognition is a service we launched last year at re:Invent as well. And what it does is object and scene detection, facial analysis, some face comparisons, and also do facial recognition, right? Again, this is a very high-level services. You cannot train. You don't have access to the model. You cannot do feedback loops. It's an AI service that you can just send a picture, and it will return something to you. The APIs for object and scene detections are like that. It will return you a list of objects that it finds in the picture with confidence core, right? And the JSON that is returned in this case is something like that you can iterate through. Right? So I just upload the picture or give a reference of a picture that is sitting on Amazon S3, and then Rekognition returns to me all this information, right? So in that case, it's more about scenes and what it sees, a city, downtown, metropolis, urban, all this kind of stuff. And it can do also facial analysis. In that case, you give a picture, and then it will return confidence of how of the face. Also with the bounding box of the face, with all the features, location in the image, so you can actually do overlay on top of that. Again, the API returns JSON files, so it's very easy to do, to use. The facial search is the same. You give 2 images, and it will do face comparison. So, for example, you can have a collection of faces, unknown faces, for example, celebrity or your own annotated photos or pictures, and then you can send reference, you can send other pictures, and then it will tell you which is the most similar to that face. So it's something that you can very fast integrate in your application. As I say, it supports this kind of collection. So even if you have your own pictures of people, you can annotate them with a name, create your own collection, and then you can then do a search by face, sending another picture, and then it will return the list of the images that looks similar to that picture. All right. Again, super popular service, tons of customers that have jumped on it, and you can imagine media companies that have large amount of assets, photos, videos. A customer, for example, like C-SPAN, C-SPAN that has had video collections of politicians going live. They took the entire set of video, extracted frames every 7 seconds, sent that to Rekognition, and the entire day had the entire set of videos annotated for the entire collections of what they had. So it's very easy to use. Right? Shadi in India that use that for moderation. For example, Rekognition does support moderation and will tell you if there are pictures that might not be acceptable for your audience. Okay? The API is very easy to use. As I say, you can either upload the photo or give a reference to a photo, in that case here, that is in my S3 buckets, and then it will return you the JSON object. You can't currently do everything at once. You need first to detect the labels. If the labels tells you that there's a person, then you might want to send that to detect face API, but it wouldn't do all at once currently, right? You can, of course, do detect face API on the original photo. If he finds it, it returns that. But that's usually the questions that are happening live. And I want to show you a quick demo of how to do this. It's an application called Polyco. If you want to go on your mobile app or on your mobile phone, you can go on it and start playing with this. It's going to be live. It's been live for a while, so it's going to remain there. It uses a service like Cognito, which Paul explained very well. How it use is for doing unauthorized access to AWS services. So unauthenticated, it's not unauthorized, it's unauthenticated API access. So that means that when you use the applications, you don't have to register, put your email or stuff like this. I allow unauthorized access to it. When I do it, I don't want you to use that token to call all the other services, so I need to have strict policies for that, right? In that case, I have policies that look like this. My policy is that using the Cognito token, you'll be able to only call those three services: Rekognition, detect labels, detect face, and then polysynthesize. So you can create very secured application with Cognito using this. My S3 bucket is also, you see, there's a very important thing here, S3 get object. So that's when you create a website that you can access from the outside. You don't want to allow put objects, right? You just want to allow get objects. So this is the way to do this kind of policies. But the Cognito works like this. You get the token, and then you can call other AWS resources. In that case, that would be Polyco applications. So let's have a look how it works. Again, everything is on GitHub. It's an initial project by Martin Edwin, that was a SA manager in the Nordics, and I took when he left the company. But that's how it works. I have an index.html file here that you actually can access here. If you go at polyco.org on Hornsby, it looks something like this. I can take a picture. If you're on your mobile phone, it will start the front camera of your mobile phone, hopefully. And then you can pass some picture. For example, let's get this one. And then it will send that picture to Rekognition. And then hopefully it will, it's a very large picture, so it's take a bit of time. But you can do some optimization, of course, by first reducing locally the size of the picture and then sending a smaller picture. This is just for the sake of the demo. It's not done.
Hi, my name is Polly. In this picture I see one face. The first face is a happy male between 26 and 43 years old. I think I also see man, face, selfie and portrait.
37, straight in the middle. Good stuff. And I'm really happy 100%. That's good. So what I'm saying is, even though it's a very simple demo, is that all of a sudden you can really integrate cool stuff. Imagine this, you go into a store, you do a facial recognition, and all of a sudden you have a personalized message of that particular customer, right? This is how you would do it. Couple lines of code, nothing else. And all of a sudden you have very advanced services. You know, you have very strong face detection, face analysis. You can define whether your customer is happy at a particular place in your store, or all this kind of stuff that you could possibly imagine. All right? Like, again, the code is on GitHub, so if you want, have a look there. Yeah.
So I noticed in the picture that you've taken, if you scroll up, it seems to have some sentiment monitoring, like it says you're angry or you're disgusted or you're happy.
Right.
Which I think is really powerful for seeing maybe for using surveys or something to see
Yep.
customers happy or unhappy. Does Amazon provide sort of the reverse of what you're doing, which is a bunch of pictures where they say this is a happy person, this is a sad person, sort of almost a library to be used against this?
Right. So the question is, Rekognition gives back very powerful emotion files, indication. In fact, we support the natural emotions. Right? I think it's 7 currently, which they are. Do we have a service that does the opposite, that we would provide an emotion and get a list of images that are like this? We don't. And in fact, all the images that we use for Rekognition as well are things that from us. We don't use customers' images or things like this. So we wouldn't do that currently. Now, if it's something that is super important for your business, please do come and talk. As I said, we work backward with customers, take feedback from customers all the time. And if something that might be very interesting for us and for you, why not? Something.
It would be interesting, right, to get a whole bunch of images.
Right. Now you could build that yourself, right? Using the deep learning AMI, it wouldn't be very difficult. In fact, you would take a public image set, do the emotion analysis, and then reverse that as an API. Just give me all the emotions, the image that have been tagged with this. Or you could do this with your own pictures, right? You send a collection of 10,000 images that you have to Rekognition, but then you need to index those, the hash of the picture, right? We don't store the picture locally in Rekognition at all. We just return the ID and then delete the picture. So you would need to store that picture with an hash and then have that indexed in a database. But that's something that is exactly what customers like C-SPAN or other media companies have done, right? So all customers could look at pictures that are from a particular politician or happy. Question?
Yeah. The labels, the image labels are sort of human usable, if you like.
Correct.
But without a published dictionary of the labels, it becomes difficult to do anything mechanical with them. Is there a published dictionary of labels?
So I'm not aware of a published. So the question is, without having a published dictionary of the labels that Rekognition is using, it's very difficult to build, let's say, large-scale systems. That's pretty much what you're saying. I'm not sure if it's possible to get that. I would need to get back to you after the session and verify, because I don't want to say something stupid that is wrong. Like,
presumably somewhere in some system there has to be a list
Absolutely.
of those labels, because otherwise how the hell can you categorize against them?
right. You could send the entire library and get all the labels that you would get. That's reverse hacking, though. But I agree. Your question. It's a good question, and please let's take back. Absolutely, and let's take this back because I think it's very good feedback that needs to be. You're not the first one saying this, so it's something that needs to happen. Absolutely. Let's go back to the presentation. Then the last demo I want to do is a bit more advanced there. We're going to use step functions. Step function is actually an extension of, I would say, Lambda. I'm going to be shot for that. Sorry, all the PR teams and stuff. But it's kind of the natural evolution of Lambda in the advent of event-driven. Because if you look at how things are happening in the event-driven world, you can have sequential steps. So you first do something, then something else, right? So a step function is a service in AWS that allows you to create graphs of sequential invocation of your Lambda functions, right? For example, you have a Lambda function, and then you can say after that invocation, invoke another Lambda function, then invoke that, and you can have very advanced graph doing this. It supports 3 current models. One is sequential steps. The second is parallel steps. So you have a fan-out type of thing. So for example, you would have conversion of an image in different format done in parallel, and then store that into S3. And this is something I'm going to showcase. And the other one is a branching step, where you would have, let's say, different things to happen, for example, with different type of Lambda functions. This is the demo we're going to do today. There is a web app that is deployed locally on my computer that uploads content into S3. When this content is uploaded into S3, there's an event trigger that calls Lambda that then calls further AWS step functions. What it does is calls 3 Lambda functions, one to do the extraction and validation of the image metadata, so the EXIF thing. The other one is invoking Rekognition and store that metadata from Rekognition into DynamoDB, and then also generate the thumbnails, right? And after that, you can have very interesting applications that are very, let's say, without any infrastructures and are quite powerful. So let me show you an example. This is the application that is running locally on my computer. And here you see I just created an album called Adrian in London. What I can do is I can browse from some pictures. Let's say I'll picture a very cool bit, and then I can upload that. And you can see step by step what's happening. The photo is uploaded into S3. Then there's a trigger that calls Lambda function and step functions to do all the work. Once the state machine has been successfully run, it returns the ID of the thumbnail stored into S3, and then I can have all my metadata stored at tags for this particular image, and things like that. So you can imagine when you do photography website, media website, and you want people to upload their content, how easy it is to plug things together in very nice and smooth way. The step function that is being run is something like this. You see, I have this is in fact, it's a state machine, right? I have a start state, which extract the image metadata Lambda function here. If you would want, we could go in there. Then there's another Lambda function that allows me to store my image metadata into DynamoDB, right? And then calls Rekognition. I have another Lambda taking that image and then calling Rekognition and then adding all the Rekognition tags to DynamoDB as well. And that's pretty much it. And then here I have a branch that just creates the thumbnails, and that's just end there. So this is very easily, I have like 5 Lambda functions tied together into a flow that allows me to do very powerful applications, right? If you would want to see the code actually is a JSON file that you can directly use an API to deploy it. So allows you to do to pretty advanced things. I had the slide with the step function. So all the slides will be available, so you'll be able to see that. And that was, the demo is also on GitHub into the AWS labs, right? If you want to have access to it, how things are done. Again, those are reference demos. Don't take everything for granted. That you would still have a couple of things to do for security, all this kind of stuff. But it just gives you an idea of how to tie things together. All right. Questions? That's why I was waiting.
Just with the step function.
Right.
All your separate lambdas will be a separate thing. How is the state passed between them? Do they have to look out to the step function?
Right. So it's the service takes care of that. So you see here when I create my workflow, I can define the input of my function and then the output. And you have in the output a different let's say, a case that if successful, if not successful, you can manage all those execution details here. So all this event data. So it's something that you can manage for each of those steps.
Transformers inside the step function?
No, so step function is a service that just takes a bunch of Lambda functions and draw a graph of execution between those Lambda functions. It's nothing else, right? And it's just something that you can invoke then as, for example, a flow to start executing with an input. In that case, the first input is really the S3 bucket with the reference here. Oh. This is really the only reference I have here. My S3 bucket, the key where it is, and then the object ID. So then the rest happens between Lambda functions. The output of a Lambda function will generate, will be passed as an input for the next Lambda function and all the way down, just depending how you create your graph. As I say, and it's a graph that you can do, you can draw by hands if you want to create a state machine. There's a lot of different blueprints here. Let's say if I wanted to do parallel. And that's pretty much it. You can start coding your input and output and all this kind of stuff. But basically, you need to have Lambda functions to start invoking between those steps. Right? Yeah?
Is there an easy integration between step functions and the API gateway? Let's say if I have one request and I want to orchestrate.
So API gateway it can be a front end to a Lambda function. So absolutely, right? So you would have API gateway that is called as an external API.
I submit one request and after it's sliced into
Yeah.
system.
Yeah. So you can either do this, it's called the fan-out architecture using Lambda calling other Lambda functions without any flow, or you can have Lambda function behind API gateway calling a step functions. Absolutely, yeah. So I could actually put an API gateway in front of this architecture here very easily, right? Yeah, absolutely. It's just here it was a local application just to show how things are can be used. Yeah. Any other questions? Cool. Alive? Do we have? Oh, my gosh, I almost forgot. So there's actually there's a published dictionary of all the API types for Rekognition called Rekognition/latest, then something like DG API types. So if you call API types Rekognition on Google, I'm sure something will come. I'm unsure if it's complete, right? But at least it gives you a good idea how to do this. There was Obi Hoyi that asks, does Rekognition work on videos and live streams or only still images? So currently only still images, right? And I say customers that do use videos, but what they do is they extract iframe, also still frames every 10 seconds, 6 seconds, and then send that to Rekognition to index the video streams, right? So that's possible, but it's not live on the video. And if there's no other questions, I think it's good to have a break. I think I've gone a little bit over time, so I'm sorry about that. But thanks a lot, and have a good end of the day.